Hello everyone, welcome to the presentation of the paper Closing Change Feature Augmentation for Person Identification on CVPR 2023. My name is Ke Han. I'm from Chinese Academy of Sciences. It's my great honor to share my work with you today. In this work, to overcome the challenge of closing variations in person ID, we propose a novel closing change feature augmentation method to largely expand closing change data in the feature space. This method can automatically model the feature distribution expansion that reflects a person's clothing color and texture variations to augment model training. With this clothing change feature augmentation, the red model is enforced to learn clothing independent features inherently. Extensive experiments demonstrate the effectiveness of our method. Clothing change person ID aims to match the same person who changes clothes across cameras. Current methods are usually limited by the insufficient number and variation of clothing in training data. For example, each person only has 2 outfits in the PRCC dataset. To address the problem, we propose a clothing change feature augmentation method to augment clothing change data in the feature space. Our work is motivated by recent findings that there exist many semantic directions in the feature space. Transforming a feature representation along specific directions can result in a representation corresponding to another image data sample of different semantics. For example, in this figure, features can be transformed towards some directions to change information of clothing colors and textures, such as the blue shirt and shorts. We wish to explore such characteristics in clothing change ready model training. The method is shown in this figure. In this work, we formulate the feature augmentation as this equation. Here, Fi is the original feature vector. The heighted Fi is the augmented feature vector. Lambda is a hyperparameter, and Ai is an augmentation vector. This augmentation vector is randomly sampled from a normal distribution. The mean and variance of the normal distribution are the 0 and sigma c respectively. Our method exploits this equation to formulate the clothing change feature augmentation. Specifically, it includes 3 training phases. Phase 1 is clothing change covariance estimation. It aims to estimate the covariance vector sigma c to formulate the clothing change directions in the feature space. To this end, our method uses each person's cross-clothing variances of feature vectors to aggregate a covariance vector sigma c. However, this estimation method is rough and cannot guarantee that the covariance vector can really change the clothing information. The effective feature augmentation should change the clothing information and keep the identity property of features unchanged. So in phase 2, we formulate an augmentation generator to simulate the clothing change ID unchanged augmentation by adversarial learning. In phase 3, we train the ready model with the augmentation generator and propose an ID correlated augmentation strategy. Specifically, we perform different augmentation on the samples of the same person, which are vertically aligned examples, and the same augmentation on the samples of different persons, which are horizontally aligned examples in a mini-batch. For example, the images on the first line are all augmented into black shirts and blue shorts, and the images on the second line are all augmented into green shirts and black pants. In this way, the intra-ID clothing variations are enlarged, and the inter-ID clothing variations are reduced. This enforces the ready model to explore clothing-independent unique identity features of each person to distinguish persons. This table shows the comparison between our method and state-of-the-art methods. We can see that our method CCFA achieves the state-of-the-art levels on the clothing change ready datasets PRCC and LTCC. Here, CCFA Phase 1 is a version without feature augmentation, and CCFA Phase 3 is a version with feature augmentation. We can see that the closing change feature augmentation obviously improves the RID accuracy. This figure shows the visualization of the closing change feature augmentation by some generative method. Without the ID correlated augmentation strategy, all the clothes are randomly changed into different clothes. The ID correlated augmentation strategy can put on different clothes for the same person and the same clothes for different persons, thus enlarging the intra-ID clothing variations and reducing the inter-ID clothing variations. This figure compares the activated feature maps of two examples in Phase 1 and Phase 3. On the Block 1 feature maps, Phase 3 weakens the activations on the clothing regions, such as the shirt in the example 1 and the skirt in the example 2. On the Block 4 feature maps, activations on faces and shoulders are strengthened obviously in Phase 3. This indicates that feature augmentation makes the model focus more on the clothing-independent identity characteristics. Okay, this is all I want to share in this video. Thank you very much for your interest and listening.